Hello, and welcome to this brief demo on model-level debugging in Papyrus-RT. Papyrus-RT is an Eclipse-based modeling and code generation tool based on UML-RT. This demo will showcase the features of MDebugger, a model-level debugger for Papyrus-RT. Before we begin, I'm going to take a moment to talk about what makes MDebugger unique. Most existing model-level debuggers map debugging features from the code level to the model level. This solution is dependent on program debuggers and generated code specific to each potential target language. If there is a large semantic gap between the modeling language and the target language, the debugger may give the look and feel of debugging generated code rather than the model itself. Additionally, a change in the target language means that an entirely new set of debugging tools must be used. By contrast, MDebugger uses model transformation techniques to introduce debugging features at the model level, making MDebugger independent of the target language. MDebugger uses model transformation to create an instrumented version of user-defined models. The standard code generated from an instrumented model is a debuggable program that interacts with the debugging application to provide debugging services at the model level. The execution of generated code is hidden, and no features of the target language are visible to the user. The example model we will be using for this demo is the ping-pong model, which consists of two capsules, pinger and ponger. The capsule's behavior is defined by their respective state machines. Each state machine consists of a playing state, and a self-transition is executed each time one capsule receives a message from the other. The two capsules send messages to each other as defined by the ping-pong protocol. The pinger capsule sends a ping message to the ponger capsule, and the ponger capsule responds by sending a pong message to the pinger capsule. To debug this model, we first have to generate the debug code. Right-click on the root element of the model in the Model Explorer and select Generate Code Debug. When finished, a dialog box will appear detailing the outcome of the code generation. Next, open a terminal window and navigate to the directory containing the debug code, shown here. Run make in this directory to compile the application. You can see that the debuggable program debug.top-main was created successfully. Now we can run the application. To debug this program, we need a second terminal window. Navigate to the directory containing the debug application, and then run it. Type help to see the full list of MDebugger commands. In this video, we will use breakpoint, next, continue, run, modify, watch, backtrace, and list. First, we can use the list command to display the active capsules and their states. Note that both capsules are in their initial states. For step execution on a capsule, we can use the next command to move the execution of the capsule one step ahead, as I'm demonstrating now on the pinger capsule. Using the list command again, you can see that the pinger capsule has changed state. We can use the breakpoint or B command to set a breakpoint on a capsule. Let's try setting a breakpoint on the pinger capsule at the exit from the playing state. The continue command will execute a single capsule until a breakpoint is encountered. First we'll run the command on the pinger capsule, and next we'll run the continue command on the ponger capsule so that the whole system executes as intended. You can see that execution is stopped because the system has hit the breakpoint. We can use the watch command on the pinger capsule to check the capsule's attribute values. If we want to change a capsule's attributes, we can use the modify or M command. Let's try setting pinger's integer attribute, ping count, to 5. Using the watch command again, we can see that the attribute value has been changed successfully. To display a trace of a capsule's most recent events, use the backtrace or BT command. Finally, we can use the run command to execute the system without stopping for breakpoints. A couple of other commands you may find useful are the sequence command, which displays a sequence diagram describing the most recent messages exchanged by the capsules, and the connect command, which provides an interface for external applications to issue commands to MDebugger. We also have a graphical user interface for MDebugger, which is Eclipse-based and integrated into Papyrus-RT. A full tutorial on using the GUI can be found in the MDebugger repository. That concludes our demonstration of MDebugger and model-level debugging in Papyrus-RT. For more information, please visit the MDebugger GitHub page and watch our in-depth demo. Thanks for watching.